we are working on the least common multiple today, or what we call LCM. Alright, so our goal is to solve problems involving LCM by listing the multiples, prime factorization, and continuous division. So if you remember yesterday, we did the GCF, but I did not review prime factorization, prime numbers with you. So now I included this. Actually, this is one of the slides that we had in October. So just to recall, what are the prime numbers? Here they are. You don't need to take a picture of this. I'm gonna save this as PDF and put it as material in the Google Classroom. So the first one is 2, 3, 5, 7, 11, 13, and so on. And the last prime number in a set of 100 is 97. Also, we did prime factorization yesterday. We call it factor 3. So if you notice, you could factor out 36 starting with 6 times 6, or you could also start it with 2 and 18. You're still going to end up with the same prime factorization. All right, and this is one of those continuous division, and this is an example of this prime factorization of 36. Just a little review. Also, today we're going to be working on LCM, but I remember I went back to our lesson in October and we did LCM in October too. So but today we need it for this unit, so we go back a little bit. So the least common multiple of 2 or more numbers. So we're going to solve the LCM by listing also the multiples using the prime factorization or continuous division. So, but before we start, I want you to list down the first 10 multiples of 4 and 6. Is it writable? Yes. Okay, go ahead. I'll give you a minute to write.
It's coming soon.
I'm not sure about that. I'll let you know. I haven't heard about state test.
Mr. Colletti said that we might have it, but it'll be remotely. Yeah, he said that they were going to send us a link. When we click the link, we'll be blacked out from using any tab. Yeah,
to see, I would like to see answers. Let me see what you got. All right, perfect. Like that. And we don't even have to explain. So I said circle the lowest common factor and you underline them. That's amazing. All right, so we'll see here. I said, you guys are not reading the direction. I am so sad.
I couldn't really circle without it going on to the other ones. So I just drew like a square around
there you go. I got circled over here. So I don't need to move forward for more. So you guys are good. So you list all the multiples and then you circle the lowest common multiple. So what is the next common multiple after the 12 based on this list? Alana?
24.
We got 24. And what else next?
36.
We got 36. And then? And we could not find any on this list. So those are also common multiple, but they are not lowest. The lowest is going to be 12. So I'll see the rest of the questions and answers later on. So let's move forward. So again, finding the LCM is not just by listing. So for example, multiples of 8 and 12, you could list it down. If you could see, 24 is the lowest, but also 48 and 72 is common, but they are not the lowest or not the least. If you remember doing continuous division, so let's say for example 8 and 10, so let's list this down and let's continue dividing it by the prime factor. So the first prime factor is 2. So, and then you divide 8 divided by 2 is 4, 10 divided by 2 is 5, and then between 4 and 5, you cannot get any more common factors. So it will just be 2 and 4 and 5. So the LCM will be 2 times 2. How come this is, wait, whose work was this? I got this from one of the work that we had before. So we'll fix this. So with that said, so 8 and 5. So let's fix this problem. So the first one is, the first number we have is 8 the first prime number is 2. So 8 divided by 2 to get us 4. And then we got 10 divided by 2, we get us 5. And between 4 and 5, there's no more common factor, and the greatest common factor is 2. And we know that if we do continuous division, the LCM that we got, LCM, is the greatest common factor. In this case, we got 2. And then the remainder factor, which is 4 and 5. All right. So now we got 2 times 4 gives us 8 times 5 will give us what? 40. So get that 40. It's just like it has like a wrong information over here. That we'll still fix it by redoing their continuous division. All right. Actually, when you divide, you still had to find the common factor and break it down. So continuous division, I don't recommend when we do LCM because of what happened here. If I'm gonna go back to the examples that we got, right? So if we go back here, remember it's 4 and 5. And then you could still get 2, and then you copy 5 down. So just to take another factor out, because you have to squeeze or take out all the factors. So that's why it's supposed to be 2, 2, 2, and 5. But since we at the back of our mind we're doing only common factors, so I don't recommend continuous division when we do LCM because of that scenario, because you might forget and you might get the next multiple. Okay, so question for that one. All right, so just do the listing and prime factorization so it's easier. I mean, it's safer. So with this, we're gonna work on Savas. Let's see what this problem is. So Mark sets the diner table every 2 days and dries the dishes every 3 days. If he sets the table on day 2 and dries the dishes on day 3, on what day would Mark first perform both chores on the same day? Solve this problem in any way you like to do it. There is a table here that you could work on. Go ahead. I'll check back on you in a minute and a half. Make useful of this recording. So here I want to show you something. I was looking at your answers before, but I'm gonna make use of the table. You guys gonna tell me, explain later on using the algorithm. But here, of course, we start with day 1, day 2, 3, 4. The handwriting is 2, 5, 6, 7, 8. I'll put 9. Okay, and then we know that every second day he's setting the table. So every second day. So on day 2 he sets, on day 4 he sets, on day 6 he sets a table, on day 8 he sets the table. And then we know that on the 3rd day he dries the dishes, right? So on the 3rd day he dries the dishes. All right, he dries the dishes on the 3rd, he dries the dishes on the 6th, and he's gonna dry the dishes on the 9th. So with that said, when is the first day that he gonna do all the work? So on day 1 he is not doing work, somebody else doing the chores. On day 5 also somebody else doing the chores, and on day 7. But on what day is it that he's doing both drying and setting up? Alana?
Day 6, because that's the least common multiple between 2 and 3. So that's the day that he does both chores.
All right. So also with the table that we have here, it shows that you're using the setting up and the drawing just based on the table. It says show in any way you've chosen, right? So with your work in responses over here, you guys did the multiples of 2 and multiples of 3, and we know that on day 6 he gonna be doing both the job. So on day 6, so it was asked that you do whatever way you'd like to do it. So you guys did it in your way, so that's good. All right, I'm gonna look at the answers of the rest later on. Let's go to the next one. So this one, I will let you just do it at Sabbath later on. This is the greatest common factor problem. Let's look at the next question that we have. And this will be the last question that I'm gonna be grading you upon. So at 9 a.m., bus A and B start their routes at the main station. To complete their route and back to the main station, bus A needs 30 minutes and the bus B needs 45 minutes to complete from the station to wherever his destination is and back to the station. So when will the two buses meet again at the main station? I'll give you 3 minutes. Oh, that's too much. 2 minutes to work on this problem. All right? 10 seconds. All right, Eugia, would you like to start sharing? How will you figure out the answer for this one?
Okay.
Go ahead.
I just added the numbers continuously. Like 30 plus 30 equals 60, and then plus that is 90. And so with 45, I just added 45 and 45 and also got 90.
And then when will the two buses meet again?
At 90 minutes.
In 90 minutes. Omar, would you like to add something to that?
I agree with what Yuchia said. Because if you add 30, 60, and then 90, the least common multiple of 45 and 30 is 90, because 30, 60, 90, and then 45, and then 90. Well, they're the least common multiples, 90.
All right. So you said in 90 minutes they will meet each other. Alana, would you like to add?
Both buses would meet back at the main station at 10:30, because because the least common multiple between 30 and 45 is 90. So in 19 minutes it'd be 10:30. So they would both be at the main station at 10:30 a.m.
How do you figure out 10:30, Alana?
Well, because 60 minutes is because, well, it's not just 30 and 45, it's 30 minutes and 45 minutes, and there's 60 minutes in an hour. So since it's 90 minutes, since 90 minutes is the least common multiple, I'd subtract 60 from 90, and so I know that 1 hour, and then I'm left with 30 minutes, and 30 minutes is a half hour. So an hour and a half, if you add an hour and a half to 9 a.m., you get the final time would be 10:30 a.m.
Would you like to add to that, Selena?
Yeah, I agree with all of them, because since 30 and 45 share the common multiple of 90, the two buses will meet back at the station in 90 minutes or at 10:30 a.m.
That is correct. Thank you guys. That was a really great explanation. So they meet again in 90 minutes, and since the bus start it's 9 a.m. so and it's 90 minutes is like 1 hour and a half. They meet each other at 10:30. That is so good. Anybody got question for this problem? I'm gonna look at your answers at the end later, so we're gonna get graded as graded classwork for this one. Anybody got question for this problem or anything about this problem? No? All right. So you guys gonna go work in your Google Classroom. Go to Savas. There are only 2 questions, so you had to work in there. So I'll check back on you later. All right. Go to Savas, guys. There are like 2 exercises there that you need to do. One is GZEP and one is LCM. And if you have a question, I'm just right here. Okay?